We're going to be solving problem 38 from section 3.3-4. We have a differential equation, x double prime plus 6x prime plus 18x is equal to cosine 2t with initial conditions as shown. We're going to take the Laplace transform of both sides of the equation and come up with s squared x of s minus s plus 1 plus 6 times s x of s minus 1 plus 18x of s is equal to s over s squared plus 2. Put terms on the right and left hand side of the equation where they belong and factor everything out, so I have x of s by itself, and then I'm going to write x of s as s plus 5 plus s over s squared plus 4 with the denominator as shown. I'm going to do some 9th grade algebra and rewrite the equation like you have there. Now at that point we need to we'll look at this guy and we see, well, that's not going to factor very well. We look at that guy and we see that he's not going to factor very well. So we look at our Laplace transform table. We see that with s squared plus 4 on the bottom, that's going to be either a cosine or a sine person. And if I complete the square on s squared plus 6s plus 18, I'll see that that's going to be something that looks like e to the something times cosine or sine of something. Okay, so I see that, and so I know that's the direction I'm going. I'm going to do a partial fraction. A squared plus b, as plus b, cs plus d. The numerator is always 1 degree less than the denominator, unless I have a repeating guy in my denominator, then that's different. And now we're going to go and find my common denominator and find out what goes in the numerator, and I'm going to go look and check and see if I can find I see that s cubed has to be an a plus c, and I remember that that's a 1, and my s squared term 6s plus b plus d, and the s squared term is a 5, so I remember that. And then we have an s term 18a plus 6b plus 4c is 5, and then the unit term 18b plus 4d is 20. Well, now I have 4 equations, 4 unknowns. There's many ways I can do it, but I look at the a plus c is 1 and say, well, gee, I can just get rid of the a variable here, and then I'll have 3 equations, 3 unknowns, and then I can use Cramer's rule very easily on that. And so that's the path I'm going to take. So a is 1 minus c. I substitute that back into the other 3 equations, and now I have 3 equations, 3 unknowns in b, c, and d. And now I can use Cramer's rule and solve for something. And so I'm going to solve for b first. So I set up my Cramer's rule for solving for b. I use the stuff on the other side of the equation to substitute for my coefficients of b. There's my c, there's my d's. And I end up with b is 6 over 85, with b being 6 over 85. I can then figure out what d is, and I find out that d is 398 over 85. And then with that I can solve for c, and then I can solve for a. And now I know each of those things. I normally keep them as fractions because decimals are they look funny when I do it that way. So now I go and I put the a, b, c, and d back into the equation, and I say, well, isn't that nice? So I have something that with an s in front of it over s squared plus 4. That's going to be a cosine guy. Without the s, that's going to be a sine guy. I'm going to complete the square with the s. That's going to be e to something sine something, cosine something, and without the s, it's going to be e something sine something. So I go and I pull out. I go and I arrange my equation. Number 10 wants me to have a s over s squared plus 4 from the Laplace transform table that I put on the website or passed out during class. And then number 9 would like to have a k over s squared plus k squared. K squared is 4, so k is 4. So I can manipulate those two guys around. So I need a 2. I have 6 over 85. I need a 2, so I'll go 6 over 175. I could have made that 3 over 85 if I wanted to, I suppose. And then I do the same thing on the other side. I complete the square. I get s squared plus 3 squared plus 9. And so I have the square completed. I see that I didn't write down which Laplace transform it is. It's probably 11. And I need an s plus 3 on top. And I've already brought out these guys. So I'll bring 3 out of there. And then whatever's left over, I stick on top. And then I need a 3 sitting on top. So I change my coefficient so I can have a 3 in the numerator. And now I'm all set. I've got something that's Laplace transform number 10, number 8, number 11, number 9. I can then go and write down my my final answer. Now the issue is we need to check the final answer. So clearly if I was going to go and do that, I would take another piece of paper, which is probably what I need to do. If I had a TI-89 or Maple, I could put it in there, but because the answer is in the back of the book, I can go look, and I did that too, and I find that it does in fact check.